Welcome to the Health AI Brief, breaking down the AI shaping our world one concept at a time. So in the last episode we talked about supervised learning, where we teach a model using data that's been neatly labelled with the right answers. But what if you don't have the right answers? What if the goal isn't to predict a known outcome, but to discover new hidden patterns in your data? This is where a different approach called unsupervised learning comes in. As the name suggests, there's no supervisor. We don't give the model any correct answers or labels to learn from. The analogy here is to imagine giving a researcher a giant unorganized box containing the medical records for 10,000 patients with heart failure. You don't tell them what to look for, you just give them this one instruction: find the meaningful groups in here. The researcher would start sifting through the data, looking for natural clusters. They might find that patients seem to fall into distinct groups based on their comorbidities, their response to treatment, or their progression over time. They're discovering the hidden structure within the data without any preconceived labels. Unsupervised learning algorithms do exactly this, but on a much bigger scale. They're designed to look at a data set and identify its inherent structure. The most common type is called clustering, where the algorithm groups similar data points together. It doesn't know what the groups represent. It's up to the human clinician to then examine these clusters and try to interpret their clinical meaning. Is this a new patient subtype we didn't know existed? Does this group have a higher risk of a specific complication or particular response to certain treatments? So what is the clinical relevance of this unsupervised learning? It's less about building a specific diagnostic tool and more about discovery. It's a powerful hypothesis generating engine. It has two main important implications for our practice. First, this is the technology that will likely help us move beyond our traditional disease classifications where it might be necessary. We define conditions like sepsis or ARDS based on clinical criteria, but we know there's huge heterogeneity within these labels. Unsupervised learning can analyze thousands of variables and might reveal more meaningful data-driven subtypes of these conditions, which could pave the way for more personalized medical approaches. Second, when you see a study that uses unsupervised learning, the key is to assess the clinical interpretation of the results. The algorithm will always find clusters. The critical question is whether these clusters are actually meaningful. Do they correlate with different patient outcomes? Do they suggest a new biological mechanism? The value isn't necessarily in the pattern finding itself, but in the clinical insight that we can derive from those patterns. So that's unsupervised learning in a nutshell. It's not about a prediction, but about discovering the hidden structure in our complex clinical data.